Welcome to Lunch Break Wisdom, short ideas from the world's most influential books, designed for a quiet break between work, a commute home, or a moment to think more clearly. Today's episode explores The Elegant Universe by Brian Greene. If a brief history of time introduced us to black holes and the origins of the cosmos and astrophysics for people in a hurry gave us a rapid tour of modern cosmology, today's book takes us to the frontier of physics itself. It asks a breathtaking question. Can all the laws of nature be explained through a single elegant framework? Could one theory describe everything? Gravity, light, matter, energy, space, time? Could there exist a unified set of principles underlying the entire universe? This dream has captivated scientists for centuries. And according to Brian Greene, one of the most promising candidates is something called string theory. Before we explore string theory, we need to understand the problem it attempts to solve. Modern physics rests upon two extraordinary achievements. The first is general relativity, developed by Albert Einstein. General relativity describes gravity. It explains planets orbiting stars, galaxies moving through space, black holes bending reality itself. According to Einstein, gravity is not simply a force pulling objects together, mass warps space and time. Objects move through this curved geometry. The second achievement is quantum mechanics. Quantum theory governs the microscopic world. Atoms, electrons, subatomic particles, probability replaces certainty. Reality behaves in ways that challenge intuition. Quantum mechanics has proven astonishingly successful. Without it, modern electronics, computers, and countless technologies would not exist. Individually, these theories work beautifully. The problem emerges when physicists attempt to combine them. General relativity and quantum mechanics speak different mathematical languages. When applied simultaneously under extreme conditions, such as the center of black holes or the earliest moments of the universe, they produce contradictions. This incompatibility represents one of science's greatest unsolved problems. The universe appears unified, yet our descriptions remain fragmented. Enter string theory. String theory proposes something radical. What if the fundamental building blocks of reality are not point-like particles? What if they are tiny vibrating strings? Imagine a violin string. Different vibrations produce different musical notes. Similarly, according to string theory, different patterns of vibration produce different particles, electrons, quarks, photons. These may represent distinct expressions of the same underlying phenomenon. At first glance, this idea seems bizarre. Tiny strings vibrating beyond direct observation, yet science repeatedly teaches humility. Reality frequently proves stranger than intuition suggests. The earth moves, time slows, light behaves both as particle and wave. Perhaps vibrating strings deserve consideration too. One of the book's most fascinating themes involves simplicity beneath complexity. Nature appears extraordinarily diverse. Mountains, animals, stars, human beings. Yet physics continually reveals hidden unity. Electricity and magnetism proved interconnected. Space and time merged into space-time. Matter and energy became interchangeable through Einstein's famous equation. E is equal to mc squared. String theory extends this search for elegance. Perhaps diversity emerges from underlying simplicity. This idea resonates beyond science. Complex organizations often rely upon simple principles. Healthy relationships depend upon basic virtues. Great performances emerge through repeated fundamentals. Simplicity frequently underlies sophistication. Another astonishing implication of string theory concerns dimensions. Most people experience reality through 3 dimensions of space and 1 dimension of time. Length, width, height, time. String theory suggests additional dimensions may exist, not science fiction fantasy worlds, but dimensions curled tightly beyond ordinary perception. Imagine observing a garden hose from far away. It appears one-dimensional. Closer inspection reveals another dimension wrapped around its circumference. Similarly, extra dimensions may exist at scales too small for current detection. This idea challenges imagination, yet it also cultivates humility. Reality may extend beyond the limits of immediate perception. Throughout history, expanding perspective repeatedly transformed understanding. The Earth was not flat, the Sun was not central, the Milky Way was not unique. Perhaps further surprises await. The book also explores beauty in science. Physicists frequently describe elegant equations as beautiful. This language may seem surprising. Beauty appears subjective. Yet many scientists experience profound aesthetic appreciation towards simplicity, coherence, and explanatory power. The universe often displays remarkable mathematical order. Why this should be so remains mysterious. Why should abstract mathematics describe physical reality so effectively? The question itself inspires wonder. Another major theme concerns uncertainty and patience. String theory remains incomplete. Direct experimental confirmation has proven elusive. Critics question whether it can ultimately satisfy scientific standards. Supporters emphasize its explanatory potential. Green approaches these challenges honestly. He communicates excitement without overstating certainty. This intellectual posture offers valuable lessons. Curiosity need not eliminate skepticism. Enthusiasm benefits from humility. People frequently demand immediate answers, yet meaningful understanding often develops gradually. Science advances through persistence. Relationships deepen through time. Character strengthens through repetition. Patience remains essential. The book also celebrates human imagination. Theoretical physicists routinely contemplate realities beyond direct experience. Invisible dimensions, quantum fluctuations, cosmic origins. Imagination becomes a tool of discovery. Importantly, imagination alone does not suffice. Evidence remains crucial. Yet creativity and rationality work together. Many breakthroughs emerge because individuals dare to ask unconventional questions. What if prevailing assumptions prove incomplete? What alternative explanations exist? Innovation frequently begins with imaginative courage. Another profound theme involves our place within the cosmos. The same laws governing distant galaxies operate within human bodies. The atoms composing neurons obey principles shared throughout existence. Human beings are not separate observers standing outside reality. We participate within it. The universe has produced creatures capable of investigating the universe itself. This realization evokes awe. Perhaps consciousness represents one of nature's most extraordinary achievements. Another important lesson concerns the unfinished nature of knowledge. Many people imagine science as a collection of established facts. Green reveals science as an evolving process. Questions generate investigation, discoveries produce new mysteries, progress unfolds incrementally. The willingness to embrace uncertainty distinguishes mature inquiry. Admitting ignorance becomes not a weakness, but an invitation. Toward the conclusion of The Elegant Universe, Green reflects upon humanity's enduring quest for understanding. Across cultures and centuries, people have asked similar questions. What is reality? How did everything begin? What hidden patterns shape existence? Whether through mythology, philosophy, religion, or science, human beings seek coherence. Traditional string theory represents one chapter within this larger story. Ultimately, The Elegant Universe reminds readers that exploration occurs not only through telescopes and spacecraft, it also unfolds through thought. Equations, questions. The courage to imagine possibilities beyond current understanding. Perhaps the greatest lesson is this: reality may be far richer than common sense suggests. The universe invites humility. It rewards curiosity. It challenges assumptions, and it continually expands horizons. Whether string theory ultimately succeeds or fails, the spirit underlying its pursuit remains deeply human. The refusal to settle for incomplete explanations. The desire to unify fragmented understanding. The hope that beneath apparent complexity lies elegant order. Because on this small planet, for a brief period between birth and death, people possess the extraordinary opportunity to ask questions extending beyond themselves, to investigate mysteries spanning billions of years and unimaginable distances, and perhaps meaning emerges not through possessing final answers, but through participating wholeheartedly in the adventure of seeking them. Because every generation inherits unanswered questions, and every generation contributes something new to humanity's ongoing conversation with the cosmos. In summary, key concepts from The Elegant Universe: 1. The search for unity. Physics seeks coherent explanations underlying reality. 2. General relativity and quantum mechanics. Two successful theories remain difficult to reconcile. 3. String theory. Fundamental particles may be vibrating strings. 4. Hidden dimensions. Reality may extend beyond ordinary perception. 5. Beauty in science. Elegance often guides theoretical exploration. 6. Patience with uncertainty. Knowledge develops gradually. 7. Curiosity drives progress. Questions sustain discovery. Everyday takeaways for you. Stay open to possibilities beyond immediate intuition. Appreciate simplicity beneath complexity. Embrace uncertainty as part of learning. Cultivate imagination alongside critical thinking. Recognize that understanding evolves continuously. Continue asking meaningful questions. If scientists discovered a true theory of everything, how do you think it would change humanity's understanding of itself? Share your thoughts below and suggest future books for lunch break wisdom. Please subscribe and comment.